Hello people, welcome to the second session of data mining. Today we'll be learning about a decision tree. The main objective here is to transform the given data into a decision tree and analyze it and differentiate it before pruning and without pruning. Today we'll be doing the same. Let's take a sample data set. Let's take the data set iris. We'll put it on the process panel, and now we're going to take an operator called the decision tree. Let's connect it accordingly. Now let's look at the parameters. The criterion is depends upon the decision tree, and maximal depth is according to psychology. A human being cannot see below 20, so the minimum value should be 20. And the tick over here applies for pruning, and we'll check it. Let's run it. Yeah, this is how a decision tree looks. I'll explain you what a decision tree actually is. A decision tree is actually a structure of the given data which is divided in the form of a tree which consists of a root node, a branch, and a leaf. A root node is the main node which is at the top of it, which is the top of the tree. And the branch is the outcome of the root node, and the leaf node is actually which holds a class label. So that is how a decision tree actually is. With the help of decision tree, it becomes simpler for us to view the data in order to analyze it and act accordingly. The following output which came is done with pruning, and now we're going to check without pruning. We're going to choose now, apply. Yeah, you see, now I'm going to explain what is pruning. Pruning is the act of cutting down a section of the decision tree, of the tree, so that it becomes precise and not too complicated. You see, earlier we had more subdivisions, but without pruning, these things have been, a little bit complex. It became smaller. They have not subdivided as much as simpler as before, but it's been a little more different. This is how without pruning actually looks. And now we can actually say that a decision tree is good or bad by the performance, by the accuracy level. And now we're going to check the accuracy level through the following process. I'm going to take away this decision tree. And now we're going to add validation, X validation. This is what we add. In this X validation, we have two processes. One is the training panel and the other is testing. In the training panel, we add the decision tree operator. Decision tree. And in the testing panel, we add the apply model. Apply model. Along with another operator called performance. Now let's do the necessary connections. For the apply model, we're going to give two connections. We need to give two connections. Alright, now let's go back to the process. Well, it's connected. You need to give the average. Alright, now let's run it. Yeah. Now you see over here the accuracy level is mentioned as 94%. So that means we have high accuracy level, which is very much efficient of the data tree implication. And now there are certain applications, things which you can do to actually increase the performance level. Let's look at some of them. You can actually do it by discretization. Discretize. And now let's look at the accuracy level. It has gone down to 80%. So that means the earlier decision tree, which is not discretized, was more accurate than this one. And the number of bins over here also estimates the level of accuracy. It has gone up to 98%. So this is much more efficient than all of it. So this is how we actually do the decision tree. Thank you.